Hello guys, welcome to the new stream. Yes, it's me and not Travis today. Unfortunately Travis can't do today, so I have said I will step in and give him a hand. So he's going to be taking Thursday and I'm going to be taking today. So, where we left off with a problem where we were seeing that the UTexture 2D dynamic was causing a linker error when we were trying to actually get into compiling it. So, what I'm going to try and do today is actually change this around. Now, after reading a few things inside the manuals and the engine documentation, which not the best in the world, and also the forums, which are brilliant, I found out that actually what was happening was there's some special systems involved in the back end of Unreal Engine where everything is divided into modules. So there's a module for the engine. Now you call it the engine, but the engine is actually then split up into separate modules internally. So what I want to do is they split it up and then they give you a module for, say, chat, and a module for XMPP, and a module for sockets, and a module for different things. Now that's all inbuilt into the overall engine stuff. Now after that you take that big main module and that is called your engine. Now the problem I found with this was that you can have a tag on the on certain places called core minimal, which is what you can see here. Now core minimal basically means if that tag is applied to, say, functions or a class, you can't actually access it. You can access it to a point where you can actually interface with it. So if you want to make an interface of that class, then, or that interface, then that would be fine. But unfortunately, you can't actually include it. Now this is where, oh hey, yeah. So this is where I have to actually do a bit of modification. So we are actually today going to hopefully modify this function. So the function that I'm going to be wanting to modify today is inside this match chat. If I bring that down here. Nope, not match chat, wrong file, it's the match item. So this bit here, we had this download image node. Now this node outputs a texture 2D dynamic, which is what we have. Now unfortunately that is kind of useless. I looked around and nothing really uses the dynamic texture 2D. So what we're going to have to do is modify this engine, or modify our custom the engine we're using, so that instead of exporting a 2D dynamic object, we want it to export a array of integers, or an array of bytes. So this is where we get into a bit of a fun one. So what I can do is, if we get into the more we can go back into the more fundamental side. If I go into projects, as you can see, I've got my weirdly, and as some people pointed out in the in Discord, in the tech Discord internally, that is a really creepy face. Yeah, I don't know why I picked it, but we're switching over to a new set of icons which are built from the Twitter pack. Twitter pack is free, we can pull it, and you can actually get it if we go into here. We can go in and type Twitter emoji pack and tweet emoji. These are all of the Twitter emojis that you get on, you find on Twitter, so we can pull one up. But they are also used in Discord, as I already said yesterday on the stream. So we are probably going to be implementing these later on if we need them. At the minute, I've just changed it to the smiley face from Discord. Now, if we take this, and I have what we call a hex editor, so HXD. Now, I don't know if many people know, but what you see here is actually a digital representation. So if we go back down further into the stack of things that are happening, you've got your screen, which is what Lee usually works with rendering and things like that. But all the data you store on flash drives, on hard drives, things like that, are all made up of what we call bytes. So this is what a PNG image, which is that smiley face, looks like in its raw byte form. And you see it goes down, and there's a whole load of stuff. Now this is its text form and format. This is in its text format, or ASCII format, we should say, which is basically ASCII is a way of representing a letter or a symbol as a digital number. So for instance, this P is actually in digital terms represented as a 50. So what we're going to plan to do is actually modify this download image node, so instead of producing a texture 2D, it produces this it produces an output that has basically this, which we can then use to do things like, if we wanted to do what we're doing here with caching, if we cache this, we can convert it into its own texture, but then we can also run this straight and store it onto a hard drive and use hard drive caching later on if we ever needed to. So what we need to do is, firstly, I can show you that actually if you want to get hands onto the source code of the engine, it's actually pretty easy. If you search for Unreal Engine GitHub or Epic Games GitHub, you'll be able to find something called Sign Up. Sign Up will then give you a whole load of instructions, and basically if we go into here, it asks you to create an account with GitHub, it asks you to create an account with Unreal Engine. You can then link these two accounts together, and that will then give you access to the GitHub page for Unreal Engine, which, if I go in here and type in Unreal GitHub, is, because I've already gone through this, is here. It will then show up in your list, and this is the entire source code to Unreal Engine. This is their release branch, but they have all the old branches all the way back to 4.0. We're currently running on a branch 4.19 on our own separate GitLab's page, or we actually host our own repository that holds our own information, and we've got a copy of the engine that we are actually editing. So once you've got that, you can then clone that repository, and then what that gives you is this. Now you can then run what you then do is run setup, which will download a whole load. It downloads about 5 gigs worth of assets, so you're going to have to sit there and wait. Once it's done that, it'll then generate the project, run the generate project files, and it will give you this SLN file. If you've got Visual Studio open, installed, and I think you have to have, you have to have the C++ development side. There is there's a whole list of things you can do. It's exactly the same as installing Unreal Engine, but you just need to have Visual Studio. That will then load up and give you this. Now this is where we are running the engine. Now what I need to do is actually close this engine, because this is actually currently running, so let's update source control. So this is the engine in its raw format. Now what I wanted to do is to get that download image. So what we want to do is download image UE4 and then you can see here this download image is actually your the node that you see. So what this basically means is that it's not a task, and you've got your download image, and this is the useful thing for us is we know that it's in the UMG module. So as I said, there was different modules built inside of Unreal Engine, so plugins are basically an extra module attached to it, and to the point where your game code is an actual module to the game, to the engine. So they've got a core module system, and then they've added extra things onto that. So it's why they can change things like the UMG and things like that without having to mess around with everything else. But the useful thing is the fact that it tells us where the header file is and the source file. So if I take this and move it up into here and bring up inside here, so what we've got is we've got runtime UMG, so we want to go into the source code of the engine, and we want runtime, we want UMG, which is down here somewhere, there it is, UMG. We want, so the header file is always in public, because that's, well, it can be in public or private depending on which folder these in. It depends on if it's available externally or internally, or just internally only. Public means that you can access this file, you can access this bit of code anywhere, and also anyone else can access it if they put a module on top. As private is usually only internally in that module. And they usually put the C++ files in private and the H files in public, unless you want the H file, the actual thing, to be accessible externally. Then you would put your H file. If you don't want it externally, you put your H file into your private as well. So I'll show you that. If we go into the game 2, which is actually our game, we called it game 2 at the beginning, and it seems to have just stuck all the source code as that. We can rename that. So as you can see, we've got here game 2 private, the private folder, and then that's where all our stuff is, because and including the H files. That's because we don't want these H files to be accessible after the fact externally, so we don't want anyone to do that, to have access to any of our code really, because we don't, there's no need for people to access our code externally. So what we need to do is we want to go into Blueprint, and this is async download image. So this is the node which I showed you earlier with download image node. Now if you have a look here, it's got a few things. So you've got that U function that I showed you earlier, yesterday. You've got these things called delegates. Now delegates are a way of being able to send an event. So when you say, for instance, this one's on success and on fail, so if on success it will call that, on fail it will call that, and usually you can either, there's two ways of using delegates. You can either use it in a way where you can link them and assign them and bind them to a function or an object, but with this one is actually a new way, and I didn't actually realise you could do this, and I'm actually probably going to move a lot of the stuff we have down out of this, but this actually is all in one. So as you saw with that node, it had a it had one input, two output exe pins, and then a texture. Now what we need to do is actually, so this here is a dynamic multicast delegate. So this basically means that you can assign a event in from the engine, or an event node to it, and then anytime you call this, that event node will then get called inside the blueprint. So what we want to do is change this, so instead of showing up as a UD2 texture, which we don't want it to do, we want to convert it to a T array. Basically it's a list really. It's a static sized list that holds a set of data about set to a index. So what I can do is, if I get paint up, so you have an array. Usually the array looks like that with two square brackets. So what we can do then is, if you say you want an array of 5, so that's going to have 5. If we put this here and here, we're going to have 1, 2, 3, 4, 3, 4, 5. Just do 6. So you'll have 6 sections. Now these are all indexed, so that will be 0, 1, 2, 3, 4, 5. And inside that we can then have data, which you usually put on this side, so you give it a data type. So if we put int, we can then have 24, 42, and things like that, and each one of these will be individual, but it will be set to a certain variable of v. So you can then access this if we try delete. So if we want to then access, say, v1, that will give you 42. 42. So actually that is assigning a value, but if you assign it a value, these two will be, whatever is inside here will be equal to that. Sizing, what's up? Not much, we're just looking at a way of modifying the engine so that we can actually use the data coming from the download image node rather than having this useless object that really doesn't help me as much. So what we want to do is make a T array, and we're going to have uint 8. So what a uint 8 is if we go back to paint, a uint 8, so if you think of so as I showed you with the image, everything's built up in what we call bytes or bits, and those bytes are then built up as binary binary. So we can have a 1, 2, 3, 4. So this is what we call hang on, 5, 6, 7, 8. So if we have these 8 zeros, this is what, remember, computers work in ones or zeros. Now if you take that, this entire thing here is what we call a byte. But then we can also have, this is the one I like, this is actually called a nibble. So it's actually half a byte. Now, when I showed you that image, so if we go back to the HXD and say we put 20, okay, yep. Gonna need something a bit. Let's try 50. Okay, so 50 gives us a percent sign, as you can see here. Oh no, 25 gives you a percent sign. So what that is we take that, and I can use a calculator because handily Microsoft actually provide you with a very useful thing. So if we go into the programming part of the calculator, which probably no one here, no one ever seems to use, but it's the most brilliant thing. So what we can do is take 25, which is a percent sign, so and we want to change it into hex. So we put 25. So 25 in hex looks like this in binary. So there is actually two extra zeros at the front there, but calculator does seem to like to take them off. So this will look like on your hard disk like that. So that is your, and then if we put it, that is a percent sign in ASCII. So what we want to do is, this entire thing is called a byte, but a uint is actually an unsigned integer. So there's two different ways. Yep, I'm streaming. Unfortunately, just to recap, Travis couldn't do today, so we swapped. He could do tomorrow, so what we did was I'm going to do today, he's going to do tomorrow, and then it'll be back to normal with me being on a Tuesday and a Thursday. So that is a byte, but then a uint, an integer, is a uint 8 is a integer that has 8 bits in it. So you can have a uint 8, which is 8, uint 16, which is 16 bits. Which, am I still modding Minecraft? No, not at the minute. I've got this project to do. So once we've got that, that's a uint. So we can now use this as a uint 8, which acts as a byte. Now they don't usually have bytes in C++, so we have to just stick with a uint 8. Now we've done that, what we need to now do is go into our private and into blueprint and async task. So this is the task that is run when you when we call that download image. Now this download image, this bit here, from what I was reading, this one does a raw crep 18 or QP 18. Hello, good evening. So this static, this is actually a render thread, and as you can see up here it says not UE server. So this doesn't run on the server, it only runs on the client, which is why you have to watch some of the things because they don't say where it runs. So if you try running this on the download image on the server, it won't actually do anything. But this bit we don't actually need now. So if I have a look, this doesn't actually have anything in the header file, so we can just remove it. I'm not needing that at all. That's just extra stuff. Has any flags? That's root. Yeah. This one seems to be fine. All it's doing is creating a new object of async task, which is itself basically, and then starting it and then returning. So this is actually a task. If you have a look here, it's a async blueprint async action base. So what this does is it enables the this class to have access to the functions that are inside this class. It's kind of layering it up. What am I doing? So I am modifying the engine so that the download image node, instead of outputting a 2D dynamic texture, actually outputs an array of bytes, so I can actually use the image in a better format, because no one seems to use the 2D texture dynamic for some reason. And so that is basically creating, so that has a start function, and that's now this bit here. So once you run the start, what it's doing is it's creating, again, if it's not on Unity server, it's creating a HTTP request, because we're doing HTTP stuff, so we're going to need to use its iHTTP request system. I will go into more of that later once we get into the APIs, once I start working on the API connecting side. This then does some binding, setting URL, using the get, and processing. So once it hits the process, goes off and starts processing, but it doesn't actually come back until, so once this is run, this request process is what we call non-blocking. For the emojis, right? Yeah, for the emojis. This is non-blocking, so it means once this is run, it will go off and start doing stuff, but it will continue running. So it will enable you to, this runs a separate thread in the background that then connects to the server, downloads the image, and then once it's downloaded, it will then call this handle image request, which will then, as you can see here, has the request you sent, the response that come back, and if it was successful. So what we got here is if it's successful and is valid and is the response content greater than 0, so if you actually got some information back, this is doing some image wrapping. Now we don't actually need that because I've got a plugin that does all this for me. So what I can do is just remove this, and what I'm going to do is pull this unsuccessful broadcast, and we're going to take that out like this. And what we're really just going to do is we're going to take this, and actually I'm an idiot, I need to make sure I have the right thing. So we got unsuccessful broadcast. Now we need to get raw data. So raw data, as you can see here, is the uint array that we want, and it's actually a floating point, pointer. So what we need to do is take this. Now if we say get raw, just having a look, get image wrapper, we need to find out where it is using. Actually, let's bring that out again. So what we need to look for is where it's using the HTTP response. So it's using HTTP response here, and it is saying here. So this is getting the data that get content, get data. So this will get the raw data that comes out of that, out of the response that you get. So what we want to do is bring this up here and see what it's outputting. So it's outputting a T array of an element type. Okay. So let's see if we can then feed this into raw data. So take this, feed this, and see. And now it's constant element type pointer. So looks like we might have to use the image wrapper after all. So once the image wrapper's done that, we want to Control Z. Okay. So we can then take this, instead of returning this here, we want to take this bit here basically creates a 2D dynamic texture which we do not need. So I can take this, feed the raw data out and put this into here. And in theory that should fix this issue, which hasn't. Let's have a look. Ah, it's because it's a constant. We don't want it to be a constant. But we do need it to be constant. So it needs to be a constant. Okay, let's get the literal value of that. Oh. Happens to a T. Okay. As I said, I am not too bright on this sort of stuff, so let's see. Raw data is a constant. It has to be a constant due to the fact that this needs to output a constant. But we don't want it to be a constant here because it will then think it's an input. So to Google, what we need to do is convert non-const. Say plus plus. Because I'm a newbie. Okay. So what we can do is put T-array in data equals raw data. And then data here, and that's not right. I am half asleep, so cast to a and then bring that out there and see if that is happy or not. No, raw data. Okay, so that is now returned. Alright, and now what we need to do is build it, which is going to probably take a bit of a while. So make sure that everything is right. Detexture, and start handle, cast not pointer. If it's false. Okay, so let's do a build and see. So if we right click the UE4 and do a build, we'll see if it comes back. Right, while that's happening, is there any questions in chat? It can be anything except leaks. That's not happening. Okay. While that's happening, and we're waiting for it. Leaks. Shakar wants leaks. Well, that's helpful. I could leak the map, but I don't think. Ellie would actually like that. If I did that, she will probably murder my ass if I did that. And probably Keepek as well, because he's actually working on the map and it's severely broken at the minute. He actually asked me if I could actually remove it because he doesn't want it shown. So why is this being a const cast? So that is doing that, that's doing that. And so yeah, it's going to moan because of the fact that it can't cast a const char. That It's annoying. By the way, as I said many times, I am not an expert on C++. I've literally only spent probably a month working on this in actual C++, so I am still trying to just blunder my way. J-Dub, 80 baby, hey. Welcome to the madhouse. So the output was telling me that it didn't like the inappropriate pointer on variable height T array. Cannot have an exposed pointer after this type. But it needs a pointer of this. We need to remove the pointer. See if it is. What are you writing code for? So this is a this is a modification to the engine. We are messing around with a basic prototype emoji type system for in-game chat or instant messenger. It's literally just a prototype to see if it is any use, if we can do anything, and mostly because I also need to learn how to use C++ a bit more and get dug into the actual code itself and the engine side. As you can see, I am completely messing up all of this at the minute. So what I want to do is get rid of this damn pointer. Yeah, I don't really do much in the way of actual in the actual main game code. Well, I work on the game code, but I don't do much in the way of actual mechanical side, like towers and that, because I'm not really a Unreal Engine person. I'm more of a API infrastructure, designing things like globally scalable servers and networks and things like that. I'm not really a person. I literally properly picked up Unreal when I first started this project, so I am extremely new to this, and which is why I am sucking at the basics of code. Which is trying to just get a literal out of this, which it's not liking. So let's try actually using a literal. Cast it to a literal and see if I can get a literal out of this. No, I can't. Doesn't seem to like having that as a literal. Okay. That's not working. Why is it not working? Let's just test this by putting it as raw data 1, but we don't want the, we actually want it to be a literal, and then that will equal, so we know we can can't cast to get rid of the constant. And that will then produce that which it's happy with. So we now need to convert this which is a pointer into reference. So usually I could just do that. Which it doesn't seem to like to do, which is great. Let's have a look. If anyone in the chat wants to help, please do, because I am all about learning, and this is something I need to learn if I want to get better. Okay. Okay, maybe that will work, which is weird. I would have never thought you'd actually have done a double pointer for a literal. It can't convert type array to parameter type, so I am actually looking for this delegate, which is t-array, and that. So let's do a copy, let's do a control shift there, and we want to find, we don't really want to find in the entire solution, but hey. I will leave that to, I'll stop that, that's not really useful. So let's try building this and seeing if it will let me. For some reason Adobe Acrobat thought it would be fun to do an update while I'm sitting here. By the way, how does it sound? I didn't ask. I've been trying out some new settings. I don't know if the music is too loud, too soft, so let me know how that is. Okay, so no suitable conversion. Actually, basic Arduino and some C, that's really good. That's actually what I currently do at work. I actually am a firmware designer, so I design firmware for microchips, and also, as well as firmware for microchips, I also do software for PC, so I kind of do most of the spectrum. Not support references at the moment. Texture. So where have I gone wrong? Okay, this is one definite. We need to create a new array. Try to make one. Maybe the mic is a bit low. Okay, cool. I will try and push that up a bit. I can't hear myself, so I don't really know roughly where I am. Actually, I might have had it a bit low. So, yeah, no, that's pointing into the orange now, so that's good. So, and we can pull this into here as a blank one. Okay. Cool. So let's build this and see if this one works. Now, as I said, in programming, a lot of it is just trial and error, which I know can look boring, but hey, it's my life. So it's been like 1 or 2 years since I last did it. Oh, yeah, Arduino is a great place to start when you want to do things like electronics and electronic programming, because it enables you to get into a lot of basic understanding of the lower level of the stuff now, which is what I try and do. So actually, to be fair, when I first started coding, I started with assembly language, which was absolute hell. It was also quite fun, but hell at the same time, because you really do not have any memory management, and I'm talking about no memory management whatsoever. You have to manage everything, which in nowadays programming languages, especially the higher level ones, they sort out all the memory management for you. So 42. So great, this is pointing to a file, and pointing the file which doesn't even exist anymore. That is helpful. But yeah, Arduinos, there's a lot of boards out there now. Usually if people want to start doing computer programming, as in software programming, I usually like to say start with either Java or C++, C#. Those are the two that are they're mostly used nowadays in computer programming. Electronics, microprocessor, firmware design usually go with something like Arduino. If you want to get into things like system on a chip, and things like Wi-Fi and Bluetooth all in one, then ESP, that actually can be programmed using the Arduino library, which is quite nice, unless you want to get in, which the Arduino library is actually a C++ based system, so it's quite nice. But they've made it less, a little bit more fun and easy so people can actually get used to it. Do not support non-cast. I guess that. Let's see. What's that super? Let's try. But yeah, that's what I did. Then I got into Java after that. Well, I did a few web-based languages, PHP, scripting languages, HTML, things like that. But then after that, I got into Java, and as Marcona says, I used to mod Minecraft, and that's how I got into all of the more game-orientated stuff. And it made me learn a lot about libraries and things like that, because you can, surprisingly enough, do a lot in Minecraft. And the nice thing about doing stuff in Minecraft is that it's quick. You get an instant result. If you code something in, you get an instant result. Yes, you do have to learn a little bit more lower things like OpenGL, which, as Lee will probably tell you, is an absolute bastard to work with. But once I've done that and did that, I then started going up. I even, when I was in university, got myself a little ZX Spectrum. I went down into binary and actual coding in hex. So basically I was coding with a big book and something like and this hex editor, and I was basically doing coding like this. So it swings and roundabouts. There's a lot of different places you can look. And I think we are successful. So we've just now built a change in the. We've successfully built. I don't know if it actually worked, but we successfully built a change in this library. So the library, this module in the UMG module, which handles, by the way, all of your widget stuff. Your widget system for HUD is built around that. Moridan, enjoy. You take it easy as well. So yeah, so that the UMG handles all of the widgets that you do on screen. You can not use the widget system, but I don't know why you wouldn't. So now that's built, we're going to now local debug, and this will open our engine up. I think it's probably opened it up on a different window. No. So this local so what local debug means is it actually runs the program, and yeah, I've got to build these modules. As you can see, the project has grown. See, that's our actual game, and then we've got custom animation nodes for animating. No, Kickox is doing a lot of work with that. Discord. People wonder why the hell I stuck the Discord in. I was bored, found a library, stuck it in, just played around with it. The low entry standards, what I'm going to use later on for doing some things like the regex stuff. Plastic is our source control, XML parser. I don't actually know why we stuck that one in. I think that's part of another one, and we have what we call Audio Kinetic Tools, which is built onto a library called WIs, which is our audio engine for the game. Enables OCal and the audio guys to be able to set up different audio sections around the entire map. It's quite cool. We have it so you can walk into the at the minute you can walk into the jungle, and the different and the layers of music start getting louder and adds more layers. So it starts off with drums, and then it adds another set of drums on top of that when you start walking in. It's quite cool. Unfortunately, it's a little bit broken at the minute. It plays for absolutely everyone. So footsteps, you can hear, even if you're stopped, you can hear everyone else's footsteps. It's quite fun. So yeah, local debugging basically enables us to have this, which we can see things like your output, which is what's coming out of the printing from the engine. Usually you can see this on your log output. Gives you some diagnostic tools, things like how much memory that it's running, CPU processing, but it also enables us to do low-level braking. So we can do add in breakpoints. So we can double click on the side here and it will add a breakpoint, and then when this bit of code gets hit, it will then stop here, and we can then look into a lot of the different variables inside here. So now we've got that. So it seems to have not recompiled from the source. Why has it not recompiled? Let's have a look. And this is why I do this, because that recompile thing comes up and it's like, well, you've gone so fast I don't even know what broke. Oh, it's that linker error that we had. So I need to actually comment out that bit of code that I created. So this bit of code here, we need to just comment out, get rid of the include, because we don't need the include anymore, and we can get rid of this one. So we can now rerun this build again and see what happens. Now this might be slow. Trust me, when you first download the source code to the engine, I would suggest you give it at least 3 or 4 hours to build. It could take quicker if you've got a higher processor speed, but it takes forever. If you're running it on an actual hard drive, I find running the actual project, even though the actual project itself, if I go into my projects, video games, the Unreal Engine itself, if I open up the properties, still going up. It's about 63 gig in size. That is the source code for the entire engine is 63 gig. It stays around that. If you start adding things, it'll do things like that. If you remove things, it'll get smaller. But your engine will get big. It'll get big and it's quite slow. I usually find, even though it's big, I usually like to find sticking it on an SSD. It's probably the best way of doing it, because I find with a hard drive it actually even slows down the buildings. So project name cannot name spaces. Oh, I'm an idiot. So because we built it, I can actually go into our project here and run it and then build it, and that will build it. So yeah, running it on a SSD is probably the best. I actually have it, I have a currently having my laptop, which is what I'm running this all on. I've got two NVMe SSDs in RAID 0, and that does gives me double speed, so get to be able to build quite fast. But as you can see, it does do parallelization, so the more CPU you have, the more CPU cores you have, the better. For instance, I'm running this on my on Jenkins. We have a my server in the garage that I'm running Jenkins on has a 24 thread, so it's 12 cores, 24 threads, and that still takes time to actually build, mostly because it's running off on a hard drive and it's quite slow running that. So loading this up. So we want BGRA format. We can probably have a look later on and change that format if it needs to. I just want to see what comes out. So we're back to our engine. Okay, so now if we go into match chat item, open it up, we should see that now this is a narrator device. So we've now successfully changed a engine based node into something that can now output the texture of an array of bytes. So now we actually need to see if it will work. So let's take this, bring that into there, and then bring this on successful out. Probably not want to create the emoji yet because it's going to moan about not having anything. So what we can do is get the length of this, and we'll just on success print it. And we'll move these nodes out of the way. So we just want to print the length and see if we actually have data appear when we download. And we need that URL. So if I go back, and by the way, I'm going to do this a different way this time. So last time I showed you that the URL actually in the thing, but if I put it here, I know it's off the screen, but I don't really want to show the URL because it's actually our endpoint. We can then go into that v1 dot, and then we want emoji/smile. And as you can see here, if I can get this without showing the URL, this is actually live, and then there's the smiley face, which is there. Now we want to take this. I thought I'd change that, but okay. We're going to force that into there, and what we want to do is compile that, which it's going to moan about. Okay, so we're actually going to have to pull the download image again, and then plonk it in. Okay. Signature error. The function event on fail does not match the necessary signature or has a delegate function. Okay. Let's see why that is the case. It might be because that change is not what I wanted, and it's going to throw an error, and you will see me having a sad face because this is not what I want. Let's have a look on Google. Okay. Error on binding of. They're basically telling me it's a bug. Well, I know it's a bug because I actually just got rid of it. Where to pick up signature? delegate signature. So I must be missing somewhere. So yeah, this is now going to be a nightmare to find out, but it looks like, because I've changed it, it's not liking it. So what we'll do is we'll compile that, get rid of that error. And we're going to close this, go back into the engine. And we're going to see if this is actually being called anywhere else. Because there's probably somewhere that's holding. Well, we could try just running this and seeing if this is it. I wouldn't expect it to work. Great, as usual, you have a question that is showing and then no one's answered it. Welcome to the actual Unreal Engine answers, because no one ever seems to use them. See. Again. Here, to here. And let's have a look. If we go back in here, so we can put this in and it's going to play. Yeah. Probably going to be one. Time to do a bit more research, I think, to find out why. Let's close this. So this is what we usually get. We usually get this issue where okay, right click that, let's do a find all usage, find all references. So it's being used, it's being set there, which is, don't really need that class anymore. So that's now complaining. Why is that complaining? So we don't want texture 2D, don't want texture. Wow, I removed that and a lot of things now just died on me. Okay. Unless this needs to have a full rebuild for it to actually, might be managing the, wouldn't expect it though to. Okay, so that built, we got rid of that. Let's try actually feeding that back that way. Got it. So yeah, a lot of this is just trial and error. We can see what happens, stick a little bit of code in, see what happens. Usually you don't want to do this, you actually want to know exactly what you're doing, but unfortunately as I said, I'm new to this, so gonna just have to see what happens. And yep, we got the problem where it's not liking this again. Now, why is it saying? One. Again, it's telling me that it doesn't like that because to not support a non-constant. What we can do is, let's see what Unreal Engine. So if we go into the Unreal Engine code and let's see what it used to be again. Engine, programs, no, not programs. Source, runtime, engine. Engine we want UNG, public, blueprint, async download image. So it is actually pushing a interesting because they say you can't do that. So then why are they getting away with it? I guess it's because it's a TRA and I'm not able to use a TRA because this one's going to need another thing. Let's have a look. Google again. Multicast delegate. Blueprint info event. Here we go. And so actually we don't even now need to do that, we can just do raw data with a take that star and that. So let's see if this builds. Why is it? Let's do it though. TRA isn't delegate. Oh well. And this is why I also like it. Wrong forum. Well, yeah, that really helps out a lot when coming to do that. That one now says it's fine, but I bet you it's going to probably... have an error again. Okay, back here. Chat item. Let's see if that fixed it. It has. Okay, so it's now seems to fix. So what I did basically is found out that you have to have a if you're going to actually try sending out an array or TN array on a multicast delegate. This is a one parameter multicast delegate. You need to have it so it's a constant, and you're going to have your ampersand symbol at the end. And then what we can do is don't actually need to do a const cast because this is now invalid, and it's probably going to moan me because I have it off. Oh no. And then we got that. And of course we also want to make sure that we move this. This is one thing I've forgotten. So what does this hashtag if do? So in C or C++ or any sort of those lower level languages, the hash if basically means if this variable, this macro, in the header files in the top of the project, if that's true, then do this, and now this one is if it's false, then do this. So for instance, if it's not the server, do this, but we have to return a value or do something. So if we want, we can then do so if it's running on the server, we don't want it to, we don't want it to actually do anything really. So let's build that. So yeah, that's one thing to note, is that a T array inside a multicast has to be a constant with a ampersand symbol at the end. Right, let's load this up. Should really make this monitor my main monitor, but because at the minute it's currently loading up on the top monitor. So now we got back here, we can see match chat, and no, we don't need that, we need match item. So we've now got this, and we want to pull this length in, and we want to do unsuccessful print. Now the URL, as I said, is going to be our smiley face image, which is interesting because I'm definitely sure I changed that. Let's go into a private window. Yeah, so here you go. This is the new image that you see on a smiley face on Discord. So let's take this, put this in here, and then just neaten some of it up. It's not going to be very neat, but pull this out of the way. So if we compile this, that's now compiled. Let's run it and see what happens. We run this, and if we switch the output log because we want to see, someone is actually trying to attempt to access -1 from something, so that's really unhelpful, so we're going to hide that. It's broken. So if we go T, hi, smile, let's see, and it's printed. If you hadn't noted at the top there, then I will try and find it in this mess. As you can see there, 2,000, 200. Now, if we pull this and we go into Postman again, actually, we could probably do it inside here. Where's the options in Firefox? Web developer. Web console. Inspector. There. Okay, let's bring this up. And then we want to pull that new smile. If we send this. So we've got your new smile. Now, if you have a look at the header, content length is 815. Interesting. So from the looks of it, that is way bigger than it's supposed to be. Okay, let's try out. So now this is where we can have a bit of fun and try and work out what's happening. So if we're now, because we're running it, as you can see it's running with the side bit, we can actually do a thing where we can put a breakpoint here, so breakpoint, and then we can run it again. See all the chat, and then we do T smile, and now it's broken here. So this is now at this is stopped where it is, and as you can see here, I've got some things on the side that say. So what we want to do is have a look at the HTTP response. So we can see here this is the actual object. So inside that object we've got different things. And now what we need to do is we want to get the content length. The HTTP response is not actually going to show us, but we do raw view. Content length 815. So yeah, we have definitely got that matches up with our content length down here in our header. So why is the raw data that big? So let's have a look. Raw view object. Oh no, where was it? And here is our payload. So you can see here is our entire image. So what I can actually do is do this and do add watch. And then I don't think I can actually. So what we can do now is, if you have a look here, this is now the entire image in raw format. So as I showed you with the HXD, we're going HXD here and bring in that smile. Actually gonna want to download the smile, so if I do save and download, let me put that into project response. So as you can see here, there's your response. If we pull that into here, as you can see now, we go up to the top, we've got %, PNG on. Yep, so there it's then. So this is matching up with this, so that's great. So in theory, this is the get content. So this is the actual content. So if we go into here into raw view object, HTTP base, no, raw view object, that one, and then we've got your payload here. So we want to get that instead. So instead we might not actually need to do this, because what it's basically doing, this is taking the is converting it into an BGA RA buffer, which to be honest at the minute we don't really want. We want just the raw physical data. So let's actually, we could in theory get the HTTP response, and then we want to get the content, and as you can see here, this is returning an array of bytes. So we can just do that, and then do a unsuccessful return and clear all of this out. Now we've just got to now return this. So we'll take that, do that, and then do a double. Or not, ampersand. No, we want to convert that to a pointer, so we'll take this and then take the pointer of this. See if that works. No, it doesn't. I'll put a constant in there. No, because theory, if we run this again, see what happens. Okay, and that'll be running again. And in theory, we should now get 815 instead of the uncompressed version of it, because it's converted it into a really big texture that we don't need. We just want raw bytes that we can then use later on to store in the RAM if we want to do RAM caching, and if we want to do store on the disk as an image. And the nice thing is with this, if we store it like this, it can actually be a PNG image. So there's no need to mess around, and then once we've done all that storage side, we can then mess around with converting it to a texture after. So in theory, if I now run this, because we've modified it, this is the nice thing about modifying the engine, is that you get instant results when you want to do something. So T, oh, so as you see, 815 popped up in the corner, and I can show you it down here as well. Gotta sort this out. But so yeah, 815 has appeared here. So that is now the raw image. So that's the raw bytes of the image downloaded, and it's now stored in. It's just being printed at the minute. So let's take that, and I think the last thing I do for tonight is try and see if I can put it into a texture. So what I can do is I can do texture, and then this there's a library which actually enables us to take a image or bytes to image. So this enables us to bring in the byte array that we created, and if we give it a format of a PNG, it will then create a texture 2D out, which is much nicer for being able to do in using. So what we need to do first is modify this match chat. So instead of, no, sorry, don't want to merge, I keep going to the wrong place. We want to modify the emoji, so instead of using a texture 2D dynamic, we just now only want to use a texture 2D, which is down here. And change variable type, it's going to moan. So we take this, take the image, and we want to set brush from texture, and we can feed in that, feed in the texture, compile that, and then what we want to do then go back into the match chat item, and I usually just take this, go to and then put WB, oh nice, it's going to be okay, so create widget, and we want to take the WB underscore, which by the way I use, if you're wondering why we have WB under everything in front of things, it's because we're using a using the UE4 standard for. They have their own kind of. It's not a standard, but it's a recommendation for a set of naming conventions. So WB is always a widget or widget blueprint, as it stands for. So we want the emoji. And we want to keep texture. We feed in this. Feed out into here, and feed that into here, and that into here. And it's going to get a bit messy at the minute. Let's just feed that into here, and that into there. Okay, compile that, and we'll play. And then if we do T5 smile, we get the smiley face that's downloaded. So, and that was downloaded, that's not, because as you can see that downloaded it, gave me the file, converted it in, and then converted that PNG into a texture that we can then use. The nice thing about it is that this texture in byte form is a lot bigger. As you saw, it was nearly 2 meg rather than 800k. So 800k? No, it was only 800 bytes instead of 2k bytes. So it does optimize it down a bit, and it enables us then to take this, and I am probably going to be ending the stream a little early today, but because I've got to the stage now where this is at a nice point of stopping, the next bit will take a little while to do. But basically that got to a stage where now it will download that file, that image, store it, output that as a byte array rather than a texture 2D dynamic, and then from there it will then, at the minute is rather basic and just converts it into a texture 2D, but later on after we can use this then to store it, cache it, and basically do whatever we want really with it. We can mess around. So what I can do quickly is just neaten this up a bit, because we don't, well, we're going to need web chat later on. Don't need to print a string, and what we're going to do is take that texture, bring that into here, take that on successful. Now unfortunately, as I said, this is a prototype. The reason why I'm doing things like this is due to the fact that we're prototyping a lot of this. This is why the game, if you've noticed, has been developed so fast. It's because we are literally prototyping a load of stuff so that things like mechanics can see it and mess around with it. We're on, for instance, we're on the third iteration of Towers blueprints and the second iteration of Minion blueprints. We have, I'm not going to show you, but we do actually, sneaky thing, we do have a ping system, a very basic ping system, and also a map system as well. The mini map has been disabled and hidden at the minute because I've been requested to hide it, as we don't know who's going to have what. But and to be honest, the map's going to change anyway. So it is, yeah, 50. So what I'll probably do is end the stream here now. Thank you very much for coming and staying. Yeah, if you want to find out more, Discord, as I said, if you want to ask anything, please feel free to go into the tech discussion and ask. Usually I try to keep an eye on it. I might miss something sometimes, but thank you very much for coming, and hope you have a good rest of the evening.